Hello there, Honors Algebra 2, and welcome to Lesson 7.2, the Quadratic Formula. All right, things about to get interesting here. So our central question today, how do you solve quadratic equations through the quadratic formula? We've looked at a few different ways now to solve. You don't need to write this, but just remember we've solved by factoring. We have solved yesterday by completing the square. And this is kind of your foolproof, all-in-one method. So if neither of those work, we can use the good old quadratic formula. It's an ancient formula. The ancient mathematicians came up with this stuff way back in the day before your iPhones and all that fancy stuff. So appreciate this formula and what it can do. What is the formula? Well, it starts out pretty simple. X equals, that's not too bad, right? Negative b, okay? Plus or minus, this is getting fancy, the square root of b squared minus 4ac all over 2a. Look at that beast there. So that's the formula. You will have it with you for the time being. You should be able to memorize it over time. There's some jingles and stuff online I can share with you. I don't have my own made up, but maybe I should. And that's it. Negative b plus or minus square root b squared minus 4ac all over 2a. Now, there are some key things with this formula, okay? Remember first that your quadratic should be in standard form. So it's for things like ax squared plus or minus bx plus or minus c. And it must be equal to 0. I know yesterday it was different, but that is the key thing there. So a always goes with x squared, b is always with the x constant, and 0. And really, despite looking scary, it's really a plug in and solve type thing. So let's look at some of these and solve with the quadratic. So first off, if we look at this problem number 1, we see 5, negative 9, negative 126. That would be a beast to factor if it is factorable. Okay, and what I always like to do is start these out labeling what each is. A is 5, b is going to be negative 9, and c equals negative 126. We're set equal to 0, so we're good to go. And really from there, it's just plugging things in. Be careful with things like negatives. So our formula, x equals negative b, so it's opposite of negative 9. So that's a first little curveball there. Plus or minus square root b squared, I'm going to still put it in parentheses here, minus 4 times a, which is 5, and times c, negative 126, all that in the square root, and then divided by 2 times a, or 5. So again, just plugging all that stuff in. A is 5, so there's the 5 and the 5. B is negative 9 in parentheses, and I know it doesn't seem like much, but it will be important, and that there. Okay, so we have it set up, and really we're just going to simplify. Now, again, just be careful. So as we simplify, please, so opposite of negative 9 is positive 9. The stuff in the square root, okay, and we actually have a name for that, and it's not super important, but we call that the discriminant. Okay, discriminant, and that's everything inside the square root. It has some special things that it can do later on here, but please do that whole thing, okay, in your calculator. I know it doesn't seem like much, and the key thing, do it before the square root. So just do the stuff in pink in your calculator. So negative 9 squared minus 4 times 5 times negative 126. I see students make little mistakes here all the time, and it's frustrating because really you could just use your calculator. So that's square root of 2601. Oh man, that's big. And then all over 10. So we're getting there. We just need to keep simplifying. Square root, that's a big square root. So first, let's see if it's a perfect square. I don't believe it is 2601. What do you know? It is. It's a perfect square, 51. So what we have is just x equals 9 plus or minus 51 all over 10. Would you look at that? And since that square root, since that became a perfect, just a regular old whole number, we can split this problem up into two. Remember that with plus or minus, you have two different problems. So I like to look at it as x equals 9 plus 51 all over 10, and x equals 9 minus 51 all over 10. Again, little tiny things, okay? You're in honors, so you should already know this, but make sure you're doing the numerator operations first. Order of operations. 9 plus 51, that's simply 60 over 10, which means our answer is 6. Boop, boop, boop. And 9 minus 51 is going to be negative 42 over 10, which that'll be a fraction for us. We'll keep it as a fraction, 4.2. Let's make it a fraction here. Negative 21 fifths. Okay, so that was your first question with the quadratic equation. We're going to see some other answer types here, but really that's the same idea. So plug it all in, make sure it's equal to 0, and use the discriminant in your calculator and go from there. So pretty easy stuff for number 1 there. Number 2, okay. Jumping into this one, first off, we need to make sure we're in the right format here, and we're going to start by adding 7 to both sides. It has to be set equal to 0, okay? So we have 2x squared minus 50 equals 0. Okay, so that's the first step. Now we have some curveballs here. Let's label A, B, and C. A is going to be 2. B, notice we're missing an x term. So missing bx, which means we're going to let b equal 0. And C is going to be negative 50. Okay, it doesn't really throw much off, but when we substitute into our formula, we'll just see what happens here. So set equal to 0, A, B, and C, and then we'll start to plug everything in. So negative b, or negative 0, plus or minus square root, 0 squared, which yes is just 0, but I'm just going to write it all out here, minus 4 times A and times C. Okay. Also, key thing, this is all multiplication. So that's multiplication. I see some students that add or subtract those. All over 2 times A. With the zeros, it is a little funky, but it really doesn't throw too much off. So what we have, x equals, negative 0 is, it's really nothing important. So plus or minus, still going to do this discriminant part in my calculator. You don't need to worry about 0 squared really, but 0 minus 4 times 2 times negative 50. And we here will get 400. 400. And that's all over 4. Now, if we can break up square root of 400, which we can, that's simply going to be 20. Square root of 400 is 20. And always try to see if it's a perfect square first. So x is equal to plus or minus 20 all over 4. And again, this just means we have 2 different answers. It's either a positive 20 over 4, which is simply 5, or negative 20 over 4, which is negative 5. Bada bing, bada boom, all solved up. So substituting, don't be afraid if you're missing a variable, just make it 0 and substitute it in there. So I'll let you write that down, catch up a little bit. And with the video, remember, you can always pause, rewind, and watch again. So that's kind of the neat little thing. So that's 2. Let's check out another one here. Just a few more examples, and it's really the same process. And we'll see here. So even if you want to even try these on your own ahead of time and then watch back through, that's a great way to do it. So first step, hopefully you are thinking to yourself, we got to set it equal to 0. So we're going to add 12 to both sides. So we got p squared minus 10p plus 8 equals 0. A, B, and C. 1, 2, 3. A is 1. Okay, is imaginary 1 there. B is negative 10. And C is 8. And then plug it all in. So x equals negative b, so opposite of negative 10. And if you are comfortable, you can already make it a positive 10, but I'm going to take my time. Minus 4 times a times c all over 2a. And there we have it. Start to simplify, so just 10 plus or minus. I'm going to do all this fancy stuff in my calculator. Negative 10 squared minus 4 times 1 times 8, 68. That's all over 2. Okay, so this particular example, I made that square root huge. Let's make it a little smaller there. Okay, now 68, that is not a perfect square. So this particular problem is where we bring in our square root knowledge, and we want to break up that square root of 68 like we did in past lessons. So I'm going to keep everything else 10 plus or minus. Let's think perfect squares go into 68. Does 16? No. So let's try something a little smaller. 4. 4 and 17. So 68 is really plus or minus square root of 4 and 17 all over 2, which means it's 10 plus or minus 2 roots of 17 over 2. And again, we talked about this in the past. If these numbers outside all share a common factor, we can reduce. So please, so this is great if you're able to get here, but make sure you reduce things if you can. So 10 divided by 2 is 5. 2 divided by 2 is just 1. And really, this is the final answer. So we can't split it up into 2. Remember, there are technically 2 answers here. It means that the answers are 5 plus root of 17 or 5 minus root of 17. But you can leave it like the boxed answer up there. So not a perfect solution, so to speak, or a whole number or an integer, but it is an irrational solution. You can leave it like that, just breaking up the square roots. So tying in all of our old knowledge. Check that one out. Alrighty, let's keep it going. You hopefully are getting the hang of it. Number 4. A is 4, B is negative 5, and C is positive 5. Okay. Start to plug it all in. Negative B. I'm going to just make it positive 5 so far. Opposite of negative 5. So again, those are little shortcuts you can take. B squared. That's also something. It's going to be positive 25. This number is always going to be positive because we're squaring a negative. So just remember, if you want to kind of take some steps ahead, you can do that, but just be careful with the signs. Minus 4 times A, which is also 4, and C, all over 2 times A. And we'll start to simplify. I'm still, even though I did the b squared part, I'm still going to do the rest of that in my calculator. 4 times 4 times 5. And we get negative 55. So square root negative 55 all over 8. So here now, this is why we just did imaginary numbers. This is an imaginary solution. That's what it's going to come out to be. Okay? Square roots of negatives, we talked about, means that we are going to bring out an I Capitan, 55 over 8. And I don't believe any perfect squares go into 55. 55 is 11 and 5. And yeah, that's about it. So there is the solution. Okay, we can't fix it up any more than that. 5, 8, and I don't all share a factor, so we're just going to leave it like that there. Nothing too crazy. Let's double check that I typed everything in okay. 25 minus 4, 16, and 5. Looks okay. So imaginary solutions, make sure you break those up as well. And our grand finale, the last one here, it's really the same thing. This time, oh man, it's set equal to negative m. Don't let that scare you. Again, set it equal to 0. Add m. Make sure you add it to the right term. 2m squared minus 8m minus 24 equals 0. And let's bring on out the quadratic equation. I guess you could divide everything if you wanted, but let's just stick with the formula. X equals negative b, so 8 plus or minus square root 8 squared, 64, minus 4 times 2 times negative 24, all over 2 times 2 from there. Again, feel free to take some shortcuts if you can, but I still highly recommend the discriminant part, typing that into your calculator. So 8 plus or minus 64 minus 4 times 2 negative 24. 256 all over 4. 256, that's going to be a perfect square for us. I believe it's 16, right? 16, yeah, look at that. So we have 8 plus or minus plain old 16 all over 4. And again, since that's not a radical or it's not imaginary, we can keep going. I would recommend, again, just breaking it up first. 8 plus 16 over 4 and 8 minus 16 over 4. Do the addition or subtraction first. So we got 24 over 4, all that for a 6. And 8 minus 16, yes, it's negative 8, divided by 4 is going to be negative 2. So those are the two solutions. All right, fantastic stuff. Hopefully you got through those. Practice problems are attached as well, so you'll find those problems on the back. And really, if you just search quadratic formulas online, you can get a ton of practice problems with these. But that's the main idea of it. So don't let the scary, lengthy formula scare you. Go through, try your best, and of course, ask questions if you got them. So great stuff, guys. And enjoy, do your practice, and we'll see you guys later.